Here we are flying into section 2.3 where we're going to get some more use of our functions, but more in a linear sense with lines. Notice linear has the word line in it, so that's going to be very, very helpful. We're also going to get the concept of slope. So let's get started. We are going to, mathematicians have developed a useful measure in the steepness of a line called the slope of the line. Slope basically compares the vertical change, which we will refer to as the rise, to the horizontal change, and we refer to that as the run, when moving from one fixed point to another along a line. Okay, so let's kind of define that idea mathematically of slope. So the slope of a line through any two distinct points, meaning different points, call them x1, y1, and x2, y2, is, now we'll get the formula here in just a minute, but I want to kind of give you some terminology that we sometimes use. The change in the y, that is our vertical change. So if you remember on our coordinate plane, y is in the vertical and horizontal is the x. So we can say change in y over change in x. Science, you see the symbol delta, or the Greek letter delta, for change in. So we could also mathematically write that, change in y over change in x. I just alluded to it was also the rise over the run, so we can refer to that as well. And here is the formula. So given any 2 points, all you're going to do is find the difference in the y's over the difference in the x's. Now notice these are exactly the same, so the order of the points matters. You must stay consistent, okay? Now we do have a condition here where x2 minus x1 is not equal to 0, since that's what's in the denominator. We don't want that equal to 0 because that would be undefined. Now, the variable commonly used for the slope m, or for the slope, is m. And here's where I also say to make sure you be consistent with the order of the subtraction when finding m. Okay, so let's just practice that a little bit when we have that. Here we have 4 points, or 4 problems with points, and we're asked to find the slope of the line through those pairs of points. So again, we're going to use this formula right here, y2 minus y1 over x2 minus x1. So you could call this x1, y1, you can call this x2, y2. So we're going to take this y value minus that y value. So we're going to go negative 2 minus 4. All over this x value minus this x value, which is negative 4, minus, negative 4 minus a negative 3. Now be very careful. In the formula, it is a minus, so you want to make sure that you subtract in that sense. But here we end up having a double negative, which would end up becoming a positive. And the number on the top, negative 2 minus 4, is a negative 6. All over negative 4 plus 3, which is a negative 1. We can reduce those negatives by being a positive, and 6 over 1 is just 6. Okay? Now, if we have 4, negative 2, and negative 1, 5, what is the slope of the line that goes through those 2 points? Now, you can let this be, go from 5 minus a negative 2, or you could go from negative 2 to 5. It doesn't matter, just as long as when you're doing your x's, you come back to 4 and subtract the negative 1. You have to be consistent with whatever point you started with. So let's kind of do that. I'll go this direction this time so you see that it doesn't matter which one. When you're subtracting, just as long as you stay consistent. Okay, so I'm subtracting each one of those. On the top, we get a negative 7. On the bottom, this double negative becomes a plus. So 4 plus 1 is a 5. It is a fraction. We can't reduce it. And it is negative. So negative 7/5 would work. Remember that that is the same as if I bring that negative completely out front. Or if you did the other direction than what we did, the 5 would actually be negative. So you would end up having a 7 over a negative 5. So all 3 of these are actually all the same. Okay? All right, let's look at the third one. The third one if I do y minus y over x minus x, we have a 3 minus 3 over a negative 4 minus a 5. So 3 minus 3 on top is a 0 over this guy gives me negative 9. Now remember, 0 divided by any number can happen. It is 0. So the answer here is 0. Now, what kind of line is that? If I were to plot the points 5, 3, just approximate 5, 3 about here, negative 4, 3 about here, and that's the line that I'm looking at. Notice that I have a slope of 0. The slant of my line is 0 when I have a horizontal line. Remember that for later on. We'll see where that goes in our next little section. Last one here with these points, let's do our slope of y minus y over x minus x. I'm just ingrained in doing the second one first, but again, you can do the first one and go to the second one. Either way works. So negative 1 minus 6 all over a 2 minus 2. On the top, we get negative 7. On the bottom, we get a 0. And that is the case that we cannot do. Negative 7 divided by a 0, that is undefined. So anytime that you have that, you need to make sure that that's an undefined slope. You just don't leave it as negative 7 over 0. Now, if we kind of somewhat graph these points, this is the slope of a special line. If I go 2, 6, say it is right there, 2, negative 1 is about there. That is a vertical line this time. So when we allude to the next little section, let's look at what kind of lines are generated with each kind of slope. So the first one we had was a positive slope. So if I have my coordinate plane, where this is my x and this is my y, a positive slope of a line is going to be increasing from left to right. So if I have a positive slope, description of each means that the line rises from left to right. And you'll want to know that because they'll ask for descriptions in your practice with this. If I have a slope that is negative, here's my coordinate plane, call it x, call it y. That is going to be a line when I look left to right, it will be decreasing from left to right, call that line L. So a negative slope causes a line to fall from left to right. This is our 0 slope, and we already found that that is a horizontal line. So here's my x-axis and my y-axis. I'm just going to draw a line there, call it line L. That is if we have a 0 slope, and the description of that is that it is horizontal. And our last one is just like this, where I have an undefined slope. And so here is my x and here is my y. I'm going to just draw some vertical line somewhere, call it line L. This is if we have an undefined slope. Squeeze that in there. And the description of the line is that it is vertical. Okay? All right, very good. Now, moving on into kind of the bulk of what this section is going to give us is how to write the equation of line. We found how to find the slope of a line. Now we're going to kind of apply that and how to figure out how to write an equation of a line, which is used quite frequently when we talk about real-world problems and in higher math and such. So it is beneficial to be able to write the equation of this line to use for other projections, okay? So if we're projecting profit on a company or something like that and it's linear, then you can do some extrapolating and kind of get future values if you want. So there's going to be different forms, and this one is what we're going to be referring to as the point slope form. So I have the point slope form of a vertical line with a slope m that passes through the point x1, comma y1. So we use a lot of this notation to get our general form. Now, that point slope form is this, and you want to make sure you know what this is. Y minus y1 equals m times x minus x1 within a quantity there. And so if you're asked to write the equation of a line, you can always rely on this point slope form to write an equation of a line. Okay, this will never do you any wrong, because it will always give you the equation of a line. Now, what if there is a special point that we want to use for our x1, y1? Call it the y-intercept. Now, we looked at y-intercepts. Remember, that's where we cross the y-axis. But we're going to use this point as the x1, y1 and determine a different form or prove a different form that we have for that. So I'm going to put x1 in here, which is 0. I'm going to put b in for y1, so we get y minus b. Whoops, I say it, but I didn't write it. Okay, y minus b is equal to my slope times x minus the x value, which is 0. And I'm going to simplify this. Well, notice here, x minus 0 is just x. When I times it by m, the best I can write it is mx. And I have this y minus b. And I want to get y by itself. So if I have a minus b, I'm going to add b over to the other side. And I get this new form solved for y as y equals mx plus b. Now, this is point slope form that I started with. Using algebra, I found a different form, and that different form is what we're going to refer to on the next page as the slope-intercept form. Because, what did I just do? I just had that, scroll down to the bottom, I just said that this was my y-intercept. So notice that intercept is in the name as a slope-intercept form of a non-vertical line with a slope of m and a y-intercept of b, and that is exactly what we just proved, y equals mx plus b. So hopefully from Algebra 1, it may have been a little while, you remember this form, y equals mx plus b. So if they give you the y-intercept, and again, it's a y-intercept, not an x-intercept, you can always just throw in m and b and you have the equation of your line. Now make sure that you get the right form that they're asking for. So it says, use the given conditions to write an equation of each line or for each line in point slope form and in slope intercept form. So this one we need y equals. This one is just, we just plop into what our formula was from before, which was y minus y1 equals m times x minus x1. So you can have it on that page. All right, so very good. So here we have a slope equaling 6, that's m. Here I have an x1 and a y1. So I'm going to plug that into this form. So I'm going to go y minus the y1, which is a negative 5, is equal to my slope, which is 6, times x minus 2. So that we can simplify. We're almost close to getting our point slope form. The only simplification that I would go ahead and do is these double negatives to make that a plus. So y plus 5 is equal to 6 times x minus 2. That is your point slope form. Okay? Now, to go from that to my slope-intercept form, I need to just do y equals, okay? So I need to, first off, simplify this on this side with my parentheses by distributing the 6 through. So 6 times x is 6x minus 6 times 2 is a 12. And then to finish it off and get y by itself, I must go ahead and subtract that 5. So what I get is y equals 6x minus 17 when I subtract the 5. And this is your slope-intercept form. So they're asking for both of those forms. You want to make sure that you do that, okay? Now, here on this next one, I am going through the lines negative, or the points negative 2, negative 1, and negative 1, negative 6. The problem with this, I have 2 points, but unfortunately, to use my point slope form, I do not have my slope. But from the front side, we practiced how to find m if we were given 2 points. So therefore, I first have to find m by doing y2 minus y1, so negative 6 minus a negative 1. Those double negatives becomes a plus 1, so sometimes I shortcut it by just go ahead and making it a plus. And negative 1 minus a negative 2. So negative 1 minus a negative 2 becomes a positive 2. This gives me negative 5 over positive 1. Therefore, my slope is -5. So sometimes you might have that extra step in order to figure that out. All right, so let's choose one of these points. I don't care which one. I normally go for the first one. These, unfortunately, both are negative. If I have one point that's both positive, I would choose that one. Let's do this as x1. This is y1. And this is my m. And I'm going to plug it into my point slope. So I'm going to go y minus a -1. So y minus -1, just like over here, it became a plus. So that's why I always kind of shortcut it again to make that a +1, equals my slope, which is -5, times x minus a -2. Again, there's a double negative, so I'm going to go ahead and make that a +2. And that right there is the first condition that I need. That's the point slope form. Then I need to get y by itself. So I'm going to first distribute. We get y plus 1 is the same, equals -5 times x, and this times this is -10. And I'm going to finish by subtracting 1 over. So once you have point slope form, getting to y equals is not too bad. It may take a couple steps, but it is not too bad. Those things you should have already practiced and should have mastered by now. Okay? All right. And our last one on this type of problem says we're going to be passing through the point 1, -3 with an x-intercept of -1. Now, this is not my y-intercept, so this is not b. I can't just use y equals mx plus b. An x-intercept is where I cross the x-axis. So at -1, 0, that is my x-intercept. So what I recommend is you writing the point out so that, number one, first we don't have a slope. So we're going to have to use this point to find our slope, and then we're going to have to end up putting it into our point slope form. Okay, so let's find our slope. Let's go y minus y. So let's go 0 minus a -3 becomes a +3, all over -1 minus 1. So the top is 3, the bottom is -2. Nasty little fraction, but that's okay. I'm then going to be able to put it into my point slope form, which is right up there. So let's use, well, if we have a 0 as an option, let's use this point, okay? So let's go y minus the 0 equals my -3/2 times x minus a -1 becomes a +1. And that right there is your point slope form. You can't do anything to simplify that, except for you could just say y equals this, and that would be okay as well. But if you like to have that 0 as a placeholder, you can. Now, to solve for y equals mx plus b, it's going to be really easy because what is this? I just said it was equal to y. And I distribute this through as -3/2 x minus 3/2, and that's my slope-intercept form. So I've met each condition that they are asking us for in these problems. Okay. All right, now let's practice identifying the slopes in the y-intercept from an equation. Then we're going to use that to graph our linear function. Now, any line, as long as it's not vertical, is a function. It does pass the vertical line test. So when graphing, you must plot B first, then use your slope M to graph the next point. Remember that the slope is the rise over the run. So you go up or down first, then left or right, depending upon the sign, okay? So give the slope and the y-intercept for each line whose whose equation is given. Then graph the linear function. Now, y-intercept is always your b. M is your slope in the form y equals mx plus b. So b is always this number that's added or subtracted at the end. M is always the number with the x, okay? So let's talk about what m is here and what b is. B is the number added or subtracted, so it is going to be a 2. And m is the number next to the letter x in our graph. So what we are going to do, we're going to start from the back and go forward. So I'm going to start with B. B is the y-intercept. So I want to find positive 2 along the y-axis, and it is right there. Then I'm going to use my slope to get to my next point. Now, that slope is 3, but remember, it is kind of a fraction where we want to talk about the rise over the run. So in order to make that a fraction, if it's a whole number, we can always put that over 1. Now, a positive line is going to go from left to right. It's going to be rising. So we want to have something that looks like that. So from our point B, we're going to rise 3 in the positive direction and run 1 in the positive direction. So I'm going to go up 3 on the rise and over 1. And between 2 points, you can draw a line. Now, if I had more graph here, I could go up 1, 2, 3, and over 1, and my next point would be approximately there. Now, this 3 over 1, hopefully you agree, would be the same as negative 3 over negative 1. Those two negatives would make a positive, but in a slope sense, this tells me I'm going to go down 3 in the y direction and to the left in the negative direction 1. So I could also find a point by going down 3 and to the left 1, and notice that falls right in sync with my points for my line. So if I do that again, down 3 in the negative direction, left 1 in the negative direction. So going down is a negative direction, left is a negative direction, this is a positive, and that's a positive direction. So now I can draw my line through my points, and now I have my line that is graphed. Okay? Let's try another one of those. G of x this time is 1/3 x. Now, to find my b, I need something added or subtracted to that, but that is not there this time. So we had to ask ourselves, what can I add or subtract in order for I basically can go away? Well, I hope that you're screaming at me 0. 0 is the number we add, that we don't change anything, but it can just kind of disappear. So 0 is actually going to be my b, which means on the y-axis I need to find 0, which is right there at the origin. And my slope is the number in front of the x, which in this case is positive 1/3. So that means I'm going to rise 1 and run 3. Go in the positive direction 1 and to the right 3. So from this point, I'm going to go up 1 and over 3. Again, I can go up 1 and over 3, but I kind of out of space. It would be approximately there. I could also, in the same sense as I did over here, make both of those negative. Go down 1 and to the left 3. That would still be on my line, but give me another point. And there's the graph of that. Okay? And the last one, we're going to find m and b. b is the number added or subtracted at the end. That's going to be a +1. So I'm going to find on my y-axis where 1 is, and it's right there. This is my slope. So it is negative 3/4 is the way it's written. But I want you to understand those negatives. That negative out front doesn't really help me in the directions for finding my points, whether I go up or down. I need to move that negative up to the top or down to the bottom as negative 3/4 or 3 over negative 4. I don't care which one that you do. Each one of them are equivalent to this, but these are going to be the better version in order to find my next point. So let's start with this first one. This tells me in the y direction I'm going to go down 3 and to the right 4. So down 3, 1, 2, 3, to the right 4, 1, 2, 3, 4 gives me that point. And this one tells me in the y direction I'm going to go in the positive direction, which is up. And this is going to tell me to go left 4 in the x direction. So 1, 2, 3, 1, 2, 3, 4 gives me this point right here. It does line up with the other two. That's good. I can draw that line. And realize if my slope is negative, it should be falling left to right. So I did get the right direction. Okay. All right. Our last two on this page are going to be specific horizontal and vertical lines in their equations, okay? So a horizontal line is always going to have something y equal to a number. Now, this says f of x equals 3. Remember, f of x is the same as y. So I could take that out, or I could also write this as f of x equal to a number, okay? So either one of those is going to be the equation of a horizontal line. A vertical line is where I just have x equal to a number. So these are the special cases when you don't have both x and y's in your equation. You know it's going to be a special line. All right, so if I have y equaling 3, and we saw some of these in chapter 1, if y equals 3 and I look at a t-chart, y always has to equal 3. I can choose whatever x values that I want, and then I can plot those points. But here's another way that I have kind of figured out works with students. If it's y equal to some number, so here y equal 3, where on my y-axis is 3, it's right here. That line, that special line is going to go through that same axis. So it's going to go through the y-axis at y equaling 3. Hence, we have a horizontal line. Here, if you plot those points, I'd have that point, and that point. So it would line up with it. Here, on this equation, notice I just have one x, no y value. So I need to solve for x by subtracting 6 from both sides. 3x equals negative 6. Then I'm going to divide by 3 to get x by itself. So x equaling negative 2. X equaling to a number is the equation of a vertical line along the x-axis, whereas negative 2, it is right here. And remember, it goes through that same axis. So I have a line where x is going, whoops, that's not very straight, but x equaling negative 2 is that vertical line that goes through negative 2. Now, if you like the t-charts, in this case, negative 2 is always going to be my x value. I don't care what y value that I choose. Again, you plot these points, you would have this point, and this point. Drawing the line through there gives you the same thing. So very much focus on those types of things. Okay? All right, very good. We do have two last little concepts here. One is another form of your line. We have our point slope form. We also have our slope-intercept form. But in some cases, books will ask you for standard form, general form. That's what we have here. Maybe I put standard form. Your book refers to it as general form, so you may want to fix that. But here is what that is. Every line has an equation that can be written in the general form. What I want in there. And the general form that we have for this book, other books I've seen it to be different, is ax plus by plus c equals 0. So in this book, the general form is defined to be equal to 0. In other books I found, and you don't have to write this down if it's going to confuse you, is that general form or standard form is equal to this, okay, where the constant is over here on this side. So know that there are differences there, but that's okay. A, B, and C are going to be real numbers, and A and B are not both 0, okay? So we need to rewrite the given equation in slope-intercept form. It is in general form. We need to get y equals for slope-intercept form. And then we're going to give the slope and y-intercept, and we're going to graph the function. So we should be masters at graphing the functions and telling the slope and y-intercept. What we now need to do is get y by itself. Now, if we want to keep that positive, notice it's a positive 6y. That means I'm going to have to move over this and that. And in order to do that, I need to subtract the 3x, and I'm going to write that first to get my mx plus b form. And then I'm going to add the 12 to get a plus 12 on this side. And when I divide by the number next to the letter, because I need to get y by itself, or y equals mx plus b, then I'm going to reduce this guy right here and separate it away from the x. So I'm going to reduce that fraction as negative 1/2 times x. And then 12 divided by 6 is a positive 2. So what is m here? What is b? B is the number at the end, added or subtracted. This is going to be a 2. And my m is the number in front of the letter, which is negative 1/2. Now notice I kind of leaned that negative up towards the 1, so let's use that in order to graph. First, graph your b. So on the y-axis, because it is the y-intercept, we're going to start at 2. And my slope tells me to go down 1 to the right 1. Negative direction 1 to the, or right 2, excuse me, down 1 to the right 2 gives me this point. Down 1 to the right 2 gives me that point. If I look at that slope as this, that means I'm going to go up 1 to the left 2. Up 1 to the left 2. Now, I would recommend doing 3 points. If you can't get 3 points in there, 2 points is good, but you don't have to do more than that if you don't want. Okay, so there again is that linear function graphed for us. And our last little concept here is graphing by intercepts. So we've just graphed these lines with our slope-intercept form, but we've also talked about X and Y intercepts before as well. So as a reminder, here is an X-intercept, and let's say this is a Y-intercept. And each one of those X-intercepts and Y-intercepts have something very special. If I were to ask you what the value of this is, we would go out some X value, but nothing in the Y direction. So here we have some X comma 0. Here, I don't go anywhere in the X direction first, but I do go down the Y, so I have 0 comma Y for that point, for a Y-intercept. So that's going to be helpful. For every Y-intercept, our X is equal to 0. For every X-intercept, our Y is equal to 0. And that's going to help us find our intercepts in an equation of general form, and then we can plot those 2 points to find that, okay? All right, so to find an X-intercept, let Y be 0, because right here our Y value is 0. Find a Y-intercept, we're going to let X be 0, because for every point our X is 0. And I like to do that just with a T-chart. Let X be 0, let Y be 0, and then I get to plug them into my equation, okay? And what's nice about one of them being 0, when you plug 0 in there, that term is completely gone. So that means I can then, if that's gone, that means what I'm left with is 5y plus 15 equals 0, and that's an easy peasy two-step equation that I can solve by subtracting 15 and then dividing by 5. Therefore, my y value is at -3, so the y-intercept is at 0, -3. Which over here on my graph is right there. And then if I let y be 0, this term now is gone. So I'm left with my 3x plus 15 equals 0. And again, if I subtract 15, I get -15. Divide by the number next to the letter. Therefore, x is -5. So my x-intercept now is -5. So on the x-axis, we're crossing at -5. And here we have 2 points that we can connect to create that line. And so I think those are a lot easy if you have general form. But definitely if you have y equals mx plus b, it shouldn't be a problem to get that graph on paper. So that's what our first little introduction is with lines. Looks like our next section is going to be more on slope, so we're not out of the woods with this yet. So practice these. Again, practice does make perfect. Let's do a little mastery of some of these topics, and then we'll move forward in section 2-4. Until next time.